Saturn's icy moon Enceladus is one of the most intriguing objects in the solar system. We know that this moon has a vast ocean beneath its frozen crust, and it could be humanity's best chance at discovering life elsewhere in the universe. But we've also noticed that Enceladus is way hotter than it should be, and scientists have no idea why. In today's video, we're going to talk about what this mystery heat might mean for our understanding of the solar system and the search for extraterrestrial life. This is the space race. The first measurements of Enceladus temperature came from NASA's Voyager spacecraft back in 1980. At the time, Voyager was simply passing by Saturn and its many moons and only had a few days to observe the system before moving on to explore the rest of the solar system. Scientists were able to determine that Enceladus was emitting more heat than it was receiving from the sun, but they didn't have any way to measure how much heat it was emitting or where it was coming from. They just knew that something was giving off excess heat, and they labeled it an enigma. A decade later, NASA launched the Cassini orbiter to study Saturn and its moons in greater detail. By 2005, Cassini arrived at the ringed planet and began taking measurements of its surroundings. The probe would make regular reports on the amount of heat given off by Enceladus, and scientists began to develop theories about where it was coming from. As Cassini continued to orbit Saturn, it made several close flybys of the moon Enceladus. The mission had been planned years in advance, so these flybys weren't exactly unexpected, but scientists still needed to verify their theories about the moon's heat signature. By 2008, scientists had developed a model of Enceladus that allowed them to measure the amount of heat it was emitting and compare that to the amount of heat it was getting from the sun. Their model looked like a layer of ice on top of a layer of rock, and they used data from Voyager and Cassini to calculate how much heat was coming from each layer. To their surprise, the ice wasn't generating any heat. All of the excess heat seemed to be coming from the rocky mantle underneath. But there was a much bigger surprise around the corner. In April 2006, Cassini flew past Enceladus on its 78th orbit around the planet Saturn. During this flyby, it detected large amounts of water vapor coming from the moon's south pole. A day after the flyby, Cassini passed over the moon again, and scientists observed a plume of water vapor rising 300 kilometers up through Enceladus crust. The plumes were shooting 250 miles into space. With the discovery of these plumes, scientists realized that there must be water from the subsurface ocean seeping up through cracks in the crust and then vaporizing when it hit the frigid surface. This discovery raised even more questions than it answered. Why was the ocean water boiling? Where was the heat coming from? These questions would keep scientists busy for the next 10 years as the Cassini probe continued to gather data. But eventually, they came to a conclusion. The source of the heat, they decided, had to be the tidal forces caused by Saturn's gravity. We'll get to the theory in a moment, but first let us take a minute to discuss the other major discovery that Cassini made while studying the plume from Enceladus' south pole. It turns out that these plumes contained organic molecules, which are the building blocks of life. It didn't prove that there was life on the moon, but it did suggest that all of the ingredients for life were present. Not long after this discovery, researchers began to refer to Enceladus as the moon that could harbor life. Okay, now let's get back to the heat. So, scientists theorized that the heat coming from Enceladus' core was generated by tidal forces caused by Saturn's gravity. This is the same phenomenon that causes the tides here on Earth. As the moon rotates around the planet, the gravitational force of the moon causes the water on the side of the Earth facing the moon to bulge out and slightly heat up. The same thing happens on Enceladus, except because it's much closer to Saturn, the gravitational pull is thousands of times greater. The thing is, scientists soon realized that the heat coming from Enceladus couldn't be explained by Saturn's tidal forces alone. There just wasn't enough energy being transferred from Saturn to the moon to account for the heat signature. So they started looking elsewhere for an explanation. That's when they discovered the radioactive elements. Scientists estimate that there are around 2 pounds of uranium, thorium, and potassium in Enceladus' core for every 1 million pounds of rock. That doesn't sound like a lot, but remember that the core is only about 15 miles in diameter. That means there's a high concentration of radioactive material packed into a very small area. If these elements were decaying inside the core, it could generate enough heat to power the ocean and create the massive plumes of water vapor. It sounded good, but there was a problem with this theory as well. Radioactive decay happens over billions of years. Yet the ocean on Enceladus appears to be relatively young. Researchers say it probably formed sometime after the moon had cooled and hardened. The moon itself is around 4 billion years old, but the ocean may have formed only 50 million years ago. That's a huge difference. Even if there were radioactive elements in the core, they wouldn't have had enough time to heat up the ocean. So scientists went back to the drawing board. Finally, one of the lead researchers came up with another theory. What if there was an energy source deep within the core that had nothing to do with the moon's formation? What if it was something new? Of course, it's impossible to prove this theory without drilling down to the core of Enceladus, which isn't exactly feasible right now. But scientists think it's worth exploring. In 2018, researchers created computer models to try to explain the origin of the heat. One of the models assumed that the heat was coming from radioactive decay. Another model assumed it was coming from Saturn's gravitational pull. And a third model attempted to combine both factors. The results showed that neither Saturn's gravity nor radioactive decay could produce the heat signature by themselves. But when combined, the two effects produced a heat signature that closely matched the one detected by Cassini. "It's really hard to explain the amount of heat that comes out of this thing," said one of the researchers who led the study. "All of the available evidence points towards some sort of internal heat source. Unfortunately, this heat may not have anything to do with the ocean." Researchers believe it's coming from the rocky mantle deep under the ice. And while the mantle and the ocean are connected, they aren't the same thing. As far as scientists can tell, the mantle is mostly solid rock, but it does contain pockets of liquid water that may be conducting heat from the core to the surface. But it's possible that the energy in the core has nothing to do with the ocean. It could be a completely separate phenomenon. For now, we just don't have enough information to be sure. But as we continue to learn more about Enceladus, we may also learn more about what's powering the mysterious heat. And that could help us understand how the entire solar system formed. After all, Saturn's moons are some of the most diverse in the solar system. They range from massive moons like Titan to small moons like Methone. Studying these moons will give us a better understanding of how Saturn formed and evolved over the last few billion years. There is no doubt that humanity has achieved some amazing things since we first launched Sputnik into space over 60 years ago. But there's still so much of the universe left to explore. That's why it's more important than ever that we continue to invest in space exploration and research. Thanks for watching. Do you think there's life on Enceladus? Let us know your thoughts in the comments below. And be sure to subscribe for more videos like this one.